Hello, everybody. We'll start our lesson. Dear students, please listen carefully. So, what was it, the last unit? The last units, uh, how can you find the prime factors of HCF and LCM? And that's why I want to show you one of an example about this title. Okay, let's start the lesson. Where's my, okay, pen? I found it. Now, let's go on. So, what's the question? Determine both the HCF and LCM of the following numbers. Exactly, prime factors of these two numbers. So how can we find the prime factors of 72 and 108? Let me remember. 72 divided by 2 and 36, 2 and 18, 2, 9. 2 is not divisible by 9, but 3 is divisible by 9, and 3, 3, and 1. Okay, these factors are prime factors of 72, and we can write it here: 2 times 2 times 2 times 3 times 3. Okay, the factors of 72. And what about 108? Let me write here: 108 divided by 2 is 54 to 70, 27, sorry, and 27 is not divisible by 2, because the product, the sum of two digits is 9, and 9 is divisible by 3. That's why we can divide by 3, and 9. 9 also divisible by 3, 3, 3, and 1. Okay, the prime factors of 108 also here we can write, sorry, 2 times 2 times 3 times 3. How many times? 3 times 3. Okay, so it's 72. The prime factors of 72, and this one is 108. And what was the LCM, or sorry, HCF of prime factors? We should take the same common factors of common, how can I say, values of both of them. 2 is here, also here. We have 2, okay, and 2 times 2. One of them are right in here, and 2 is here, but here is we have 3, that's why we cannot write it. And but here, 3 and 3, right, one of them. And here also 3 and 3, you can write 3, and the others are left. That's why the answer is 2 times 2 is 4, 3 times 3 is 9. The answer is 36. Is HCF, okay, don't forget. And every time HCF is less than maybe than LCM, it's HCF of prime factors. And what about LCM? Also same numbers, okay? How can we do it? Well, let's continue from here. What was the 72 and 108? The prime factors of 72 is 2 times 2 times 2 times 3 times 3. And write all prime factors of 108 is 2 times 2 times 3 times 3. Okay, now we can write all of them. Okay, we cannot left that. That's why 2 times, how many 2 there is? We have 3 plus 2 is 5, or 2 power of 5. You can write the powers: 2 times 2 times 2, and times, how many times 3 is 5 times also, 3 power of 5. Okay, right. I have written directly 3 power of 5 and 2 power of is equal to 5. Okay, where's my calculator? Let me check it. What's about 3 times 243 and times, and 64 or 32, 32. Okay, I'm writing here. Please follow me, my pencil. And is equal to times. What was that? 3 power of 5 times 3 times. Sorry, 3 times. 3 times. 3 times. 3 times. 243 and times 32 is 7,000. So there we have multiplication, and 7,776. Okay, it's LCM, the prime factors of LCF. Sorry, LCM. Okay, LCM of 72 and 108, the prime factors of 72 and 108. The others also, please listen again. If you don't understand, then check yourself. Okay, so today, if you read here, divisibility tests are not part of the syllabus. What does it mean, syllabus? You can check with your dictionaries, okay? And they are just useful to know when you work with the factors and prime numbers. So this part is not in our education year. It's not the part of syllabus, but it's useful to know. So that's why you should know that also this part of the math. Okay, divisibility tests to find factors easily, for example. Sometimes you want to know if a smaller number will divide into a larger one with no remainder, without remainder. For example, I want to know, can I divide 30 by 4 without remainder? No, I don't know, because I don't know this way, okay, these methods. If you know these methods, you can choose easily. For example, it's 7.5 and or 7 and the remainder is 5. And that's why we have remainder, but we need it without remainder. How can you find? Or can you say directly 30 is not divisible by 4? How can it say it? How can I tell it? So these simple divisibility tests are useful for working this out. A number is exactly divisible by 2 if it's divisible by 2 without remainder. How can you do it? If it ends with 0, 2, 4, 6, or 8, we have large number, for example 1,258 is a big number. That's why we don't know it's divisible by 2 or 4 or 5. Okay, for example, can we divide by 2 without remainder? Yes, exactly, because why? The last digit of this number is 8. 8 is even number. In other words, is even. So these digits are even. If our number's last digit is even, so this number divisible by 2 without remainder, no remainder. Okay? And the next number is 3. If it's divisible by 3 without remainder, the sum of its digits is a multiple of 3. For example, 1, 3, 7, and 1 is also a big number. How can you know it if it's divisible by 3 without the remainder? So we should take separate the digits of this number. 1 plus 3 plus 7 plus 1 is equal to 12. 12 is divisible by 3 or multiple of 3. 4 times 3 is 12. That's why this number is divisible by 3 without remainder. Okay, and can be divided by 3. And a 4, if the last two digits can be divided by 4, last two digits. For example, this number 71. 71 can divide by 4. 71 is not divisible by 4. Okay, and 71 is prime number. For example, 58. 58 also not divisible by 4 or not multiple of 4. That's why these two big numbers are not divisible by 4. And the other example I want to write here, 16, 20, and 16 is exactly divisible by 4 because 16 is the multiple of 4. 4 times 4 is 16. And a 5 if it ends with 0 or 5, for example. 1, 2, 3, 5, 6, 0 is divisible by 5. Yes. Why? Because the last digit of this number is 0. And in a rule written 0 or 5 if the last digit is 0 or 5. So this number is divisible by 5 without remainder. And a 6, what about 6? If it is divisible by both 2 and 3, because the multiple of 6 are 2 and 3. And that's why, for example, 2, 8, 5, 4, 3. And if it's divisible by, what was the 2 and 3? Let me check it. 2 was, the last digit is 0, 2, 4, or even is not even. That's why this number is not divisible by by 6. And what about 3? It's the sum of digits or multiple of 3. The sum of digits, 3 plus 4 is 7, 12, 20, 22. 22 is not divisible of 3. That's why this number also not divisible of 6. Okay. And 8, what about 8? If the last 3 digits are divisible by 8, last 3 digits divisible by 8. Now, because 8 is even number, and if it's divisible by 2 and 4, now you can write it. Yes, 8, this number is divisible by 8, but 2 and 3 is not divisible by 6. That's why also this number is not divisible by 8. Okay, last 3 digits are divisible by 8. If the sum of the digits is a multiple of 9, can be divided by 9. If the sum of digits is multiple of 9, and for example 27, the sum of these two digits is 9. 9 is multiple of 9, exactly 1 time 9 is 9. Or 36, the multiple of, there is 6 is 9 also. 1 time of 9 is 9. And last one, if the number ends in 0, okay, is divisible by 10 without remainder. Okay, so there is no simple test for divisible by 7. Although multiples of 7 do have some interesting properties that you can investigate on the internet. Okay, thank you. Exercise 1.10, 23, blah, 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 blah. There is, we have some numbers. And what was the question? Look at the box of numbers above. Which of these numbers are divisible by 5? Okay, what was the rule of 5? Let me check it. 5 is here. The last digits must be 0 or 5. And the last digit is not 0 and 5. That's why it's not divisible by 5 without remainder. But that last digit is 5. That's why it's divisible by 5 without remainder. And that 2 is not. 0 is okay. 4 is not. 0 is okay. 0, not okay. Not. Okay. So from here, 4 numbers is divisible by 5 without remainder. The others is not divisible by 5 without remainder. And by 8. What was the rule of 8? If the last 3 digits are divisible by 8, I mean it's also the sum of last 3 digits of these numbers are 8. 1 plus 0 is 0. Sorry, 1 plus 4 is 5. This 5 is not divisible by 8. And here also the last 3 digits is 2 plus 2 is 4, plus 3 is 7, not multiple of 8. And here also 17 plus 7 is 24. 24 is multiple of 8. 3 times 8 is 24. That's why this number is divisible by 8. Let me check with my calculator. Where's our eraser? Okay. In my calculator is not divisible by 8 without remainder. So let me check it again. If it's 798, the last 3 digits is divisible by 8. 7 plus 9 is 16, plus 8 is 24. Yes, here. 24. 24 is the multiple of 8. That's why it must be divisible by 8. But the answer is 99.75. If the last 3 digits are divisible by 8, the last 3 digits, maybe here 8, and about here is 9 and 7. Okay. Sorry. And the last 3 digits are divisible by 8 is not divisible by 8 because of it has got some remainders. That's why it's not divisible by 8 without the remainder. Okay, here not the sum of 3 digits, just last 3 digits. Okay, so and on mine, sorry, here and by 3. What was the by 3 rule of 3? The sum of its digits is multiple of 3. The sum of its digits. For example, the sum of these numbers is 2 plus 3 is 5. 5 is not multiple of 3. It's not divisible by 3 without remainder. And 11, not 11, 1, 5, 7, 5, 3. Okay, it's multiple of 3 is 1. That's why it's divisible by 3 without remainder. And 9, sorry, 10, 10 not divisible by 3. And here, 24 is 8, a multiple of 3. That's why it's also divisible by 3 without remainder. And here, 3 plus 5 is 8. 8 is not multiple of 3. That's why it's not also divisible by 3 without remainder. Okay. And say whether the following are true or false. Divisible by 5. What was the rule of 5? The last digit must be 0 or 5. The last digit is 5, and that's why it's divisible by 5. And what was the 6? Is divisible by 2 or 3. 2 is divisible, yes, because the last digit is 0, 2, 4, 6, 8, or even numbers is also divisible by 6. Yes? Or let me check it. It's not divisible by 6 without remainder. Uh, what is the rule of 6? Is okay. 2 and 3. That's why, and not also only 2, but 3 also must. How can I say? If it's divisible by 3, then we can say it's okay. It's divisible by 6, and the sum of digits multiple of 3. The sum of this number is 10. 10 is not a multiple of 3. That's why it's not divisible by 6. And 8. Last 3 digits must divisible by 8. Let me check with the calculator because we haven't any more time. That's why 8 is 59.5. Also not divisible by 8. And a 6, 2 plus 10, 19 is prime numbers. That's why it's not divisible. And the 5 last digit is 0 is 5. Okay. So the others for you, please check yourself at home. Can $34.07 be divided equally among 2 people? When you divide 34.07 by 2, you will get 17.035. Okay, the equal part. And 3 people, it's 11.356. And repeating decimals. Okay, 66666 plus infinity. That's why it's repeating decimals. That's why it's not, how can I say, to equal part. And 9 people, when you divide this number to 9, also 3.78 and 5 repeating decimal. That's why it's not x. The x is okay. So first option is equally among. It's divided equally among. And the powers and the roots. What about powers and roots? Square numbers and square roots. A number is squared when it's multiplied by itself. For example, the square of 5 is 5 times 5 is equal to 25. And the inverse of this expression is square roots. And the powers and square roots. And the symbol for square is square. Okay, so 5 times 5 can also be written as 5 squared or 5 power of 2. And a square root of a number is a number that was multiplied by itself to get the square number. The symbol for a square root is, this one is our symbol. And you know that 25 is equal to 5 squared or 5 power of 2. So in a square root, 25 is equal to 5. Okay, cube root is also the same methods you can follow, but there's some difference. Things there is we have in this case, a number is cubed when it's multiplied by itself and then multiplied by itself again. For example, the cube of 3 is, 2 times 2 times 2 is cube of 2. Or you can write 2 power of 3 is 8. Okay? And the inverse of 8, or in cube root of 8, in cube root of 8 is 2. In cube root of 8, you can write 2 power of 3, and the power of root also 3. As cancellation, just we have 2. There's some explanation. You can read. The cube root of a number is a number that was multiplied by itself to get the cube number. The symbol for cube root is in cube root. You know that 8 is equal to 2 power of 3. So in cube root, 8 is equal to 2. Okay, it's square cube, square number, arranged to form a square shape. And here we have cube, can be arranged to form cube shape, solid, exactly. Okay, and finding powers and roots. You can use the calculator to square or cube numbers quickly using the x square or x cube keys, or the x square and blah blah blah. So worked example 8. Use your calculator to find 13 square. 13 square means 13 times 13 is equal to 169. And 5 cube is, it means 5 times 5 times 5 is 25 times 5 is 125. Okay. And the others also for you. So how can you find the square roots of, for example, this number? First of all, let me check it. Which number's square is 324? Or can I write x? What is the x? I mean, it's 18. 18 square is 324. And it goes out just 18. So x is 18. Okay. And also here, 512, you can find it, but there's we have not square, but cube. That's why which number's cube is equal to 512. You can use your calculator, and here also 8, written 8. 8 times 8 times 8. Okay, 8 times 8 is 64 times 8 is equal to 512. 12. Okay. There's some examples of exercise 1.11 and calculate. First of all, 3 square is not difficult, is 9, and 7 square is 49, and 11 square is 121, and is equal to 121. So the others also is not difficult. You can choose yourself. And second exercise, calculate 1 power of cube, about cube, 1 power of cube, or 1 power of 3 is equal to 1, because 1 times 1 times 1 is equal to 1. Okay? 3 power of 3 is 27, because of 3 times 3 times 3 is 27. And the others also not difficult. Please check yourself. And I'm going to solve some hard questions here from here and about the last units or last titles. For example, option C or 5, exercise 5. Use the product of prime factors given below to find the square root of each number. Show you working. Okay, how can find these prime factors? Just we can use the methods of HCF and LCM. 324 divided by 2. Okay. And what about 324? Let's use our calculator. Is 116. 162 divided by 2 is 81. Is not divisible by 2. That's why 3 is divisible by 3. Is 27. 3, 9, 3, 3, 3, 1. 1, 2, 3, 4. There is 3 power of 4 times 2 power of 2, or 2 square. And here also you can, as you see here also, 3 times 3 times 3 times 3 is 3 power of 4, and here also 2 times 2. So the prime factors, how can you find the prime factors of 324 is these numbers? Square root each number. Okay, just you can show these methods to finding the prime factors of 324. And the last, sorry, second number of exercise is 784. 784 divided by 2, and you can use the calculator, okay? And the next prime number is 2 also. And the next also, as we have 2 power 4, 4 times 2, and 2 times 7 is our prime factors of this number, okay? So, and the last one, use the product of prime factors to find the cube root of each number. So you are working. 27, just we are writing here, 27 divided by not 2 by 3 is not divisible by 2. That's 1, 9, 3, 3, 3, 1. And how can I write these numbers? 3 times 3 times 3, or 3 cube is 27. Okay. So thank you for your attention. See you in the next lessons.